Welcome to the video on fluid bed granulation critical process parameters. In this video we are going to learn regarding critical process parameters CPPs, critical material attributes that is CMA, and critical quality attributes that is CQAs. Fluid bed granulation is also called as or known as granulation by top spray in the pharmaceutical industry. There are different types of granulation like dry granulation and wet granulation. So dry granulation are made by direct mixing or dry mixing using blender and slugging method and by using the roller compactor. Wet granulation methods can be made by different means in which rapid mixer granulator is used and also fluid bed granulator is used. Fluid bed granulator is also called as fluid bed processor. It is very similar to fluid bed dryer. Many times, fluid bed dryer and processor are the same equipments. Topspray granulation may be aqueous or non-aqueous, and in topspray granulation or FBP based granulation, simultaneous binder addition and drying is performed. Granulation is performed in the closed environment, and in these different unit operations like granulation and drying is not done, but the granulation and drying is done at the same time in the same equipment. There are many advantages of top spray granulation over RMG granulation. Top spray granulation produces the granules which are porous in nature and generally which have good flow properties and the dissolution or solubility behavior. The top spray granules are generally less hard and are porous in nature compared to the granules prepared by the rapid mixer granulation process. Let's start with the critical process parameters which are related to the CQS. So critical process parameters are those parameters which affect the critical quality attributes of the final formulation. First is percent occupancy of the bowl, or you can say the batch size. You can also say it like fill level of the bowl or the percent occupancy. The main CPPs are inlet air velocity or fluidization, inlet air temperature, inlet air humidity and dew point, inlet temperature, bag shaking interval and frequency, spray rate, product temperature, automation air pressure, gun position, gun to bed distance, and number of nozzles in the gun and the nozzle size. If the occupancy is more than optimum, it will impact the granulation. Granules may not be proper. If the batch size is too low, then the spray may get affected and proper granulation will not be there. So optimum batch size should be selected. Inlet air velocity, fluidization, air volume. So considering the batch size, this factor is varied. Inlet air or fluidization air volume affects the fluidization, and due to fluidization the granulation process is affected. Inlet air temperature, this is the temperature which is important for keeping the bed temperature in the specific range so that overweighting should not happen and also drying should not happen. So it should be proper and it is required to be adjusted as per the product. Also inlet air temperature is dependent onto the granulating solvent, whether the granulating solvent is water or whether the granulating solvent is non-aqueous. Then outlet temperature. Outlet temperature is affected by the inlet temperature, the inlet air volume and the spray rate, bag shaking interval and the frequency. See, in the FBP granulation, the bag is attached at the top so that the air moves out of the fluidized bed and the powder is retained into the bowl. But many times what happens is that the powder sticks to the bag and bag is required to be shaken in specific intervals so that the bag doesn't get choked and the inlet air is properly heated and the material is fluidized and then it leaves the fluidization chamber. Spray rate. This is very important parameter and it is very critical. Spray rate is required to be adjusted as per the batch size, inlet air temperature, product temperature, and the drying behavior of the product. If spray rate is more than optimum, agglomeration will happen. If spray rate is too low, then the binder solution may get spray dried. Product temperature. So, product temperature is important for making the granules dry and also making the agglomerates. So if product temperature is too low, that time also agglomeration will happen, and if it is too high, then spray drying may happen and granules will not be formed. Product temperature is dependent onto the product behavior on case by case basis and also the binder solution. Automation air pressure. Automation air is used to spray the liquid binder and to convert the liquid binder into the mist. If automation air pressure is too much, that means the binder solution will convert it into very fine particles, and if automation air is too low, then the binder solution may get poured like a pump, like we uh, add the liquid by pump. So automation should be proper, should be optimized, uh, and then it is fixed. Automation air pressure is required to convert the binder into fine droplets. Gun position, gun to bed distance, number of nozzles in the gun. So gun position affects the spray pattern and the spray zone. Then number of nozzles affects the spray rate. If only one nozzle is there, then spray rate is required to be adjusted according to that. And if 2-3 nozzles are there, then spray rate will be high at less pump RPM also. So adjust the spray rate according to product temperature, adjust the atomization air pressure, and adjust the pump RPM to force the binder into the gun. Then nozzle size. So nozzle size is the aperture size of the nozzle. If the nozzle size is big, that means it can spray more amount of binder in less time, and if nozzle size is less or smaller nozzle size, then you cannot spray more binder in a specific time. These are the CPPs. Main CPPs are inlet air temperature, inlet air volume and velocity, or it is called as CFM, spray rate, product temperature, automation air pressure. These are the main process parameters. Now some of the machine related parameters are there which affect the CPPs, like equipment design. Different equipments are designed for the fluid bed granulation, bed height or bowl capacity, bowl design, gun type and nozzle size, number of nozzles in the same gun, and the nozzle design, finger bag type and the mesh size. It is also very important. Product specific finger bags are utilized. Size and retention mesh size. These are the critical equipment related factors which affect the CPVs. Now coming to the critical material attributes. So what are the attributes of material affecting the fluid bed granulation? API and excipients which are there in the batch. Sometimes API is dissolved in the binder and that API solution is sprayed. Sometimes the API is suspended and it is sprayed. So API and excipients of the batch or product affect the product sequence. So these are called as critical material attributes. Mainly the density of the dry mix blend, density differences between the different materials, flow of the materials, particle size differences and particle size of the different excipients and the APIs. Then static charges, adhesive and cohesive nature of the powder blend affects the granulation process, affects the CPPs, affects the total processing time, and that's why these affects the critical quality attributes of the product. Binder viscosity and granulating solvent. So if binder is too much viscous, then the CPPs are required to be adjusted according to that. If granulating solvent is water, then that time the product temperature is high around 40-45 degree, and if the granulating solvent is non-aqueous or hydroalcoholic, that time we need to keep the product temperature low. Then total binder quantity, API load in the blend. These are the CMAs for top spray granulation. API excipient ratio is also there. Whether the API is in a high quantity or high level, low level or medium level. Are the lubricants and glidants are used in the dry mix blend? Sometimes to improve the granulation process, some glidants are used. Then the API load, PSD and density differences, flow differences, adhesive and cohesive nature. These are the critical material attributes. Coming to the critical quality attributes. So critical quality attributes will be first for the granules, then for the lubricated blend, and then for the final product, which may be tablet or capsules or sachets. Bulk density, tab density, flow properties. These are the critical quality attributes of granules. Blend assay and blend uniformity for the lubricated blend. Then if you are using this blend for tablets or capsules or sachet, then physical and chemical sequence of the tablets and capsules or sachet formulations will get impacted. So for tablet, it might be hardness, disintegration time, dissolution time, weight variation, sticking picking. Then for capsules, it will be flow, uniformity of weight, disintegration. Then for capsules, it will be filling, whether the tamping is required or not, whether the slugs are to be prepared for capsule filling or not, will be the critical quality attributes. And final chemical attributes will be assay, content uniformity and dissolution. Sometimes if you are converting the API into amorphous form, that time the crystalline nature or amorphous nature will be the CQA, then dissolution will be the CQA, assay and content uniformity will be the CQA, and also sometimes the formation of impurities or related substances, degradant products will be the CQS. So these CQS are based on to the formulation type. This was the information for fluid bed granulation regarding CPPs, CMAs and CQS. I hope you might have got uh, good learning out of this video. Whenever you are working on to the top spray granulation, that time remember these points and proceed for your granulation. Thank you for watching the video and let's meet soon with such kind of informative videos.